This year was the 14th time. So we're always searching for speakers and ideas that go above and beyond what we know from the state of the art.
At the IROS 2024 conference, the 14th workshop on Planning, Perception and Navigation for Intelligent Vehicles was successfully held. This workshop invited 6 speakers in the field of autonomous vehicles and intelligent transportation systems to share innovative topics on perception, planning, and navigation, attracting many scholars to come up and communicate. Professor Johannes Betz, as the moderator and one of the organizers of this workshop, has also been shortlisted for the New Generation Star Project selection held by NOKOV Motion Capture. NOKOV invited Professor Johannes Betz to share the organizing experience of the themed workshop and research results in related fields.
My name is Johannes Betz and I am an assistant professor of the Technical University of Munich, and I'm researching in the field of autonomous intelligent vehicles and mobile robotics. This year was the 14th time. So in the last couple of years, we heavily focused on getting innovative topics. We wanted to have speakers that are researching in the field of autonomous vehicles and intelligent transportation systems who are working at the forefront of technology. So we're always searching for speakers and ideas that go above and beyond what we know from the state of the art. We saw that especially in the field of unstructured environments, we have a lot of knowledge gaps. Uncertainty coming from the sensors, uncertainties in the motion planning. How can we model intelligent transportation systems? How can we optimize them? Or for example, how to have intelligent infrastructure, which means sensors that are above and provide information for autonomous vehicles in megacities. So we are focusing here on the complete software stack of autonomous vehicles, which means perception, planning, and control. That means we have topics in the field of perception, like object detection and localization. We have topics in the field of motion planning, how to generate fast trajectories. And finally, control. How can we steer the car optimally, especially with high uncertainty?
Professor Johannes Betz has been focused on the field of autonomous vehicles and has published more than 75 papers in international conferences and journals. The latest paper, NOKOV Motion Planner, High Performance and Modular Trajectory Planning Algorithm for Complex Autonomous Driving Scenarios, proposes a high-performance and modular trajectory planning algorithm based on sampling that adapts to complex autonomous driving scenarios. This algorithm effectively addresses the challenges of space construction and optimization in path planning, and is suitable for real-world environment simulation, providing a powerful solution for complex autonomous navigation.
Our contributions to the autonomous driving community are an optimized motion planning algorithm for comfort, safety, and precision, a modular design for enhanced adaptability, scalability, and simplified integration, and ultimately a high performance. We provide Python and C++ implementations, ensuring flexibility with both real-time capability. And this is Frenetics for autonomous driving motion planning, which is released on GitHub.